This is the example problem for Unit 2, Specific Heat Problems, Complete Problems 2. This problem says, a beaker contains 40 grams of water, specific heat of water, is 4.18 joules per gram degree Celsius. The water cools from 93.5 degrees Celsius to 38.5 degrees Celsius. How much energy is released? We see in the problem that there are 40 grams of water, that will be the mass. We see the specific heat. We know that joules per gram degree Celsius is a unit that indicates specific heat. We also see two temperature units. So because the temperature is changing, we have the mass and the specific heat, and we're looking for energy, we can use Q equals mc delta T. We're looking for Q. We know M and C. We don't know delta T, so we can use this equation to calculate it. Delta T equals final minus initial temperatures. The final temperature of the water is 38.5 degrees Celsius. That's the temperature it ends up as. It cools from 93.5 degrees Celsius, so that's the temperature it starts as. So delta T equals final, 38.5, minus initial, 93.5 degrees Celsius. That gives us negative 55 degrees Celsius. You can plug in Q, just leave as Q because we don't know it yet, we're looking for energy, equals 40 for mass, 4.18 for specific heat, negative 55 for temperature. Multiply all those together, you get negative 9196 joules. The question asks how much energy is released. So because it's phrased that way, it takes this absolute value here because that's how many joules of energy are leaving. A negative number isn't released. This many are released. So the answer to plug in here, 9196 joules.